Here we go with Math 1 systems practice. So the idea here is we're given a system of equations, and there's three ways we can solve it: elimination, substitution, or graphing. Now, I provided a graph for everyone if you want to graph it by hand. You can also use the graphing calculator to graph, or Desmos. Okay, on your phone, the app, or the website desmos.com. Okay, that helps make it a lot easier and more precise if you use graphing. Now, is it always the best way to do it? Not necessarily. Sometimes there's quicker ways, but it just kind of depends on the equation and how well you are at doing it. Okay, I'm going to try to, for the most part, show you all how you do it on all three ways. Okay. You've also got to remember that when we're dealing with linear equations, there's three different possibilities for the types of answers you're going to get. Okay, you either get ones that intersect, and they'll only intersect once, so you can have one solution, and it'll look like a point. You can also have two lines with the same slope and different y-intercepts, so they're parallel, so they're never going to touch, so the answer is no solution. Or you can have two lines, well, one line pretending to be two, where they overlap. Okay, so that is, infinite solutions because they're always touching, so any solution works. Okay, so we may see some of these types, and we can look at how we see them graphically and how we see them algebraically. Okay, so the first one to graph would be easy. It's in slope-intercept form, so -2. I can even graph it by hand quick. Slope of -1, so down one to the right one, or up one to the left one. Okay, so there's our first. Oh, that was a horrible line. There's our first. That's a little better. Okay, y-intercept of +1, slope of -4/1, so down 4 to the right 1, or up 4 to the left 1. So we can easily see where that one's going. And despite my best efforts at not making it work, it would actually intersect right here. That's really where it should have went. Okay, so that is an x value of 1, a y value of -3. That's the solution to this system of equations. Okay, now let's see what it would look like if we did elimination. So do they all line up? Yeah. So we have a 1y and a 1y, so the way to get that to eliminate is subtraction. So 1y minus 1y is 0y, equals -x minus -4. That'd be like plus. So -1 plus 4 would be a +3x. Then -2 minus 1 would be -3. So then I add 3 to both sides, because that's like 0. So I get 3 equals 3x. Divide by 3, and we get 1 equals x. Okay, there's our x. Then we take one of these equations, replace the x with a 1, and then we get simplify. -1 minus 2 is -3. There's our y value. There's our answer in elimination. Okay. Now, let's suppose we decided to use substitution instead. So how would it look as substitution? Well, I've got a y by itself, so I take this and I substitute it in for y. So -x minus 2 equals -4x plus 1. Simplify, add 2 to both sides. We get -x equals -4x plus 3. Add 4x to both sides. -x plus 4x is 3x. Equals 3. Divide by 3. There's our x equals 1 again. Then we take one of our original equations. We put the 1 in just like we did with elimination. Let's do the other equation this time to show you that it also works. So -4 plus 1. -4 plus 1, -3. So there's our -3. So you can see that it doesn't matter if you use elimination, substitution, or graphing. They'll all get you the proper answer, if you do it right, of course. And you can see substitution and elimination actually have a similar part at the end. So number 2. So this one, let's start out with elimination or substitution, because with the fractions we'd probably be scared to do one of those. So if I start a substitution, this is all equal to y, so I replace it there. So I got 7/3 x minus 4 equals negative 1/3 x plus 4. So I could add 4 to both sides. I get 7/3 x equals negative 1/3 x plus 8. Then I could add a 1/3 x. So we've got the same denominator, so 1 plus 7 would be 8/3 x equals 8. To get rid of my fraction, I times by 3. That becomes 8x equals 24. Divide by 8, and x equals 3. Okay, if I used elimination, I didn't finish, did I? So then I take one of these equations, so y equals negative 1/3, substitute 3 in for x. So negative 1 divided by 3 times 3 cancels, so negative 1 plus 4 gives me positive 3 for y. So my solution to this is 3, 3. Okay, now let's suppose we used elimination. So the y's are the same, so I'd subtract y minus y is 0y. 7/3 x, or let's just think of coefficients. 7/3 minus negative 1/3. That's like adding them. 7 and 1 give me 8, so equals 8/3 x. Negative 4 minus 4 would give me negative 8. I would add the 8 to both sides, because that's 0. So we'd get 8 equals 8/3 x, which probably looks pretty familiar, doesn't it? We times by 3. We get 24 equals 8x, divide by 8, and 3 equals x. Okay, there's our x. Then we could take the other one to show you that that one works as well, and we go y equals 7/3 times 3 minus 4. Well, dividing by 3 and timesing by 3 undoes each other, so we're left with 7 minus 4, which is positive 3. There's our y value. Okay. Now, let's suppose instead we decided to graph it, which is probably what I would suggest on this one. Okay, will we get the same answer? Y-intercept of positive 4, slope of negative 1/3, so down 1 to the right 3, or up 1 to the left 3. Okay, y-intercept of negative 4, slope of positive 7/3, so up 7/3. We draw our line. Where do they intersect? Right there at 3, 3. Okay? So it doesn't matter which version you use, it's going to work. Okay? So I think for the rest of them, because I'm not going to get through them all doing everything, I'm going to use the way that I would do it, based on how the problem is set up. Now, any way always works. Okay? If I look at 3, I've got those halves. I don't want to deal with a half with substitution or elimination. I also notice that it's in slope-intercept form, which I can graph very easily. If I'm using Desmos or something like that, I can graph that just as easy. So we graph. Negative 2 for our y-intercept, slope of 1/2, so up 1 to the right 2, or down 1 to the left 2. Okay. Then the next one, positive 4, slope of 1/2, so up 1 to the right 2, or down 1 to the left 2. Now, if I look at this, you may say, well, they never intersect. Now, could it be that they'll intersect over here off the graph or over here? It could be, so I need to look at my slopes. My slopes are exactly the same. Same slope, different y-intercept means they're parallel. Okay? Parallel lines never intersect, so my answer is no solution. Okay? Now, let me show you how we do this algebraically so that you can see. So I will have to do it again for this one. So, if I did substitution, this would substitute in for y. So I'd have 1/2 x minus 2 equals 1/2 x plus 4. And what's going to happen is as you go to solve it, okay, 1/2 x minus 1/2 x, they both become 0x, or just 0. So I'm left with simply negative 2 on this side, because this canceled out, and positive 4 on this side, because this canceled out. Is negative 2 equal to positive 4? That is not equal. This is how you see no solution algebraically. Okay, it doesn't work. Okay, you get rid of your variables and the equation doesn't work. It's the same for elimination. I would have subtracted this, y minus y is 0y. 1/2 x minus 1/2 x is 0x. Negative 2 minus 4 is negative 6. You'd end up with 0 equals 0 minus 6, or 0 equals negative 6. Even though they're different numbers, it still doesn't equal, so that's where we get the no solution. Okay, which is the answer to this one. Personally, I would have graphed it, so to get my answer. Okay, now number 4, I don't have that in slope-intercept form. Desmos works great to still graph that. If I'm sitting at a computer, I'm going to type this in and use Desmos because that's really easy to do. However, if I don't have that, this one's a substitution one for me. Okay, the reason being that y is already by itself. So I take that 3x and I replace this y with 3x plus 1. Now I've created an equation with one variable. Now I simplify. So 2 times 3x gives me 6x plus 2 minus 6x equals 2. Now 6x minus 6x is 0, so those cancel out. So this could be a no solution. I got rid of my variable, but I have plus 2 equals plus 2. Is that true? Yeah, that works. Okay, this is what we call infinite solutions. Okay, so let me show you how that would work with elimination. For elimination, I'd have to rearrange. I'd have to add the 6x to both sides, wouldn't I? That would give me y equals 3x plus 1, and in the bottom, 2y equals 6x plus 2. Now, this isn't the same, neither is this, but could I double that second equation? 2 times y would give me 2y, 2 times 3x, 3x, 2 times 1. If I do everything to every part of the equation, it's still going to work out. So now 2y, we'd subtract 2y, that would give me 0y. Oh, this became a 6x, didn't it? 6x minus 6x would be 0x. Then 2 minus 2 would be 0. So that's 0 equals 0 plus 0. So 0 equals 0. Is that true? That is true. Hence, infinite solutions. Okay, well, what does that look like graphically? Well, the best way to see it is if I take this equation and solve it for y. If I did it on Desmos, it would just end up looking like this. We graph the top, positive 1, up 3, to the right 1, or down 3, to the left 1. Okay, it would look like that, and then you'd graph the second one, and it would look like that. Okay, they overlap because they're the same equation. This one's just doubled. Okay, because if I add that 6x, I get 2y equals 6x plus 2, divide by 2, and we get y equals 3x plus 1, which is the same thing we had before. Personally, I like substitution on this, but the answer is infinite because they're the same equation. Okay? Now, if we get any more no solutions or infinite solutions, I'm going to leave it. But now you've had a good example of all of them, and you can see how to react depending on the way your answer is given. Okay? Those first two had one solution because we came up with an x and a y. Now remember that x and that y value is one solution. It's not two solutions. Okay? So, there we go. Alright, I look at number 5, and I'm going to substitute it here. That one makes sense to me. Could I graph them? Yeah, I could. But I'm not going to. So this whole thing substitutes in for y. So I get 4x plus 4 times 1/4 x minus 4 equals 4. It's a lot of 4's. This multiplying in, 4 times 1/4 is just x. So I get 4x plus x. 4 times negative 4 is negative 16. So I add 16 to both sides. I can combine those to get 5x equals 20. Divide by 5, and x equals 4. So right off the bat, I know this is not infinite solutions. It is also not going to be no solution. There is one solution here, because I already have one value. Okay, then I pick another one of these. I'm going to go with this one. Substitute 4 in for x. Then I get 16 plus 4y equals 4. Subtract 16. 4y equals negative 12. Divide by 4. And y equals negative 3. So negative 3. So that point, 4, negative 3, that's where these two lines would intersect. That's our solution. 5, to me, is one that I would use substitution for. Now, number 6, I could use substitution, or because they're in slope-intercept, I could do graphing. That would work just as easily. However, I would most likely use elimination. The reason being, it's all lined up and easy to go. And I would say a positive 2x and a negative 2x, I'm going to add these. So y plus y would give me 2y. 2 plus negative 2 would give me 0x. 5 plus negative 5 would give me 0. So 2y equals 0. Divide by 2. Y equals 0. Then I pick one of these equations and replace the y with 0. I get 0 equals 2x plus 5. Subtract 5 from both sides. Negative 5 equals 2x. Divide by 2. And I get negative 5 over 2, which is negative 2.5, equals x. So my point is negative 2.50. That's where they intersect. All right, 7 and 8. Okay, I look at 7. I've got that 3/4 x. I don't like it. I'm not going to do elimination. I'm probably going to end up graphing this, because I can change this one quickly, because I don't like that. I don't like dealing with that. But as a slope, I can deal with that. So 0 for a y-intercept, because it's like plus 0. Then I go up 3 to the right 4, or down 3 to the left 4. Okay, there's my line. Now, for this one, not as easy to graph. Okay, but I can get that y by itself by taking 3x minus 4y equals 12. Subtract 3x. That would give me negative 4y equals negative 3x plus 12. Divide by negative 4. And I get y equals positive 3 over 4x. 12 minus divided by negative 4 is negative 3. Now what I should notice, what I was going to say is I noticed that I have the same slope here. That should be key to telling me this is going to be a parallel line, so it's going to be no solution. They never intersect, they never cross. If I needed to, I could graph it. Okay, down negative 3 for my y-intercept, up 3 to the right 4, down 3 to the left 4. Okay, they're parallel, hence no solution. So, had I used elimination or substitution, you would have ended up getting rid of both variables and not having it equal to each other. Okay? Alright, let's take a look at number 8 now. So, on number 8, I'm going to use elimination, because my x's and y's and numbers are lined up. Now, I don't have the same x's or the same y's, so I'm going to have to make them the same. Well, we think of that and we think, okay, how can 3 become 12? Well, I could times it by 4. So if I times every piece by 4, because of that multiplication property of equality, it doesn't change my equation, just makes it bigger. So 4 times 3x would give me 12x. 4 times negative 4y, negative 16y. 4 times 7, 28. Now, we should notice something right off the bat. Those are the exact same equations. If they're the exact same, we know it's going to overlap, so it's infinite solutions. okay, I'm going to have the same line more than once. If you didn't believe me, we could try it. Subtract 12x minus 12x would give me 0x. Negative 16 minus negative 16, negative 0y. 28 minus 28, 0. So 0 minus 0 equals 0, which is 0 equals 0, which that's true. Hence the infinite solutions and not no solution. Alright, now number 9 looks really weird, doesn't it? Okay. So x equals 4, y equals negative 3. Honestly, you should be able to look at that and realize that the point 4 for x, negative 3 for y is the only place where they're going to intersect. Okay. Y equals just a number. That's a horizontal line. So we go to where y is negative 3, and we draw a horizontal line. X equals 4. Well, x is the value of x for 4 is right there, so that's a vertical line. Okay, so where they intersect is going to be right there at 4, negative 3. Okay, now if I look at 10, okay, this one I would probably use elimination again. So 3x, we'd have to subtract to get 3x minus 3x to be 0x. Now negative 1y minus negative 1 would add, and that'd be negative 1 plus 1 would actually give me a negative 0y as well. Okay, so this could be no solution or many solutions, because I just got rid of my variables. So negative 4 minus negative 2, that would be plus, so that would be negative 2. So this one is not true, so it would be no solution. These lines are parallel. Okay, if we graphed them, they would be parallel. Alright, 11 and 12, and 13 and 14. Okay, now 11, I look at this one and I would use elimination. Okay, could you graph it? Yes. Could you use substitution? Yes. But to me, elimination seems to be the best one for this case. So I've got the 3 y's. So if I subtract 7 minus 1, give me 6x. So I know there's an answer here. 3 minus 3 would give me 0y. 9 minus a negative 9, write it out if you have to, use a calculator if you have to, would be 18. So 6x equals 18, divide by 6, and x equals 3. Take an equation, replace the x with 3, solve for y. Subtract 3, we get 3y equals negative 12, divide by 3, and y equals negative 4. So my answer, 3, negative 4. That's the point where they would intersect. Okay, number 12. This one's also set up to work well with elimination. Negative y and a positive y, I would add those. So 7 plus 1 would give me 8x. Negative y plus y would give me 0y. Negative 4 plus negative 4 is negative 8, so 8x equals negative 8. Divide by 8, we get x equals negative 1. Take an equation, replace the x with negative 1, so instead of x plus y, we get negative 1 plus y, add 1, and we get y equals negative 3, so my answer, negative 1, negative 3. Now, on all these equations that are in standard form, they're harder to graph by hand, but if we're using a graphing calculator or Desmos, okay, they're easy to graph, and I would suggest probably doing that, because that would be really easy. Now, 13 and 14 are different, because they're not just two equations. 13 has 3 different equations. Okay, so there could be more than one answer. There could be still no solution or many solutions if they're all the same. 14 is an exponential and a linear, so that's the same rules don't always apply. So 13, if I'm dealing with 3, I'm going to probably graph them. Okay, so y equals x, so plus 0 for the y-intercept, slope of x, so we go up 1 and over 1. Okay, so there's our first line. Okay, then we graph the top one, because that's easy too. Positive 4, 3x, so I go up 3 to the right 1, or down 3 to the left 1. So we can see one intersection point, right? Okay. Now, that last one, I would have to turn it to slope-intercept form, so I'd subtract 2x from both sides. So 4y equals negative 2x plus 8. Divide by negative 4 on everything, and I get y equals positive 1/2 x minus 2. So go down to negative 2. Then we go up 1 to the right 2. Up 1 to the right 2, or down 1 to the left 2. Okay. Now, if we look at this, we've got 3 points of intersection. Do all 3 of them meet ever at one point? They don't. So for all 3 of them, there's not really a solution to that. Okay, but for these 2, there's a solution right here. For these 2 right here, and for those 2 right there. Okay, so we'd probably call this no solution because we wanted them all together. Okay, now 14. We have negative 5 plus 1, so 1. Then we're going to go down 5 to the right 1, or up 5 to the left 1. Okay. Then we have 4 to the x, so that's like y equals 1 times 4 to the x. So y-intercept of 1, and then we're times them by 4 as we go to the right. So that'd be 4, then that'd be clear up there, 16. If we go to the left, we cut it into fourths. So it's got that asymptote at the x-axis. So we follow that along and keep going up. So pretty easy to see that they have the same y-intercept, so that's our solution. It would be 1, 0, 0, 1. So that one did have a solution. Okay. All right, now these last few are pretty similar, aren't they? Okay, so this one is pretty tough to graph by itself. Okay, y equals 4, that's easy. It's a straight line right here. Okay, this one, 3x minus 3y, we could graph it or change it to slope-intercept. This would be a great candidate for a graphing calculator. So I get negative 3y equals negative 3x minus 9. Divide by negative 3. I get y equals x plus 3. So up to 3, then we go up 1 to the right 1. Okay. So far we have one intersection point right here. Okay. Now this last one, y equals 2 times 4 to the x minus 4, the best idea might be to make a table for it. So if I did 0, 0 for x, we'd have 2 times 4 to the 0 minus 4. 4 to the 0 is 1, times 2 is 2, minus 4 is negative 2. So it starts out at negative 2. Okay? Now, if we did 4 to the first, it would be 4 to the first is 4, times 2 would be 8, minus 4 would be 4. So it would be 1, 4. So it actually hit right there. Okay? So it would look something like this. Okay, so this intersects right here, but not all 3 intersect there, so that's not part of our solution. However, right here, we have all 3 of them intersecting at that point 1, 4. So my solution would be 1, 4. Now number 16 is kind of a review. It's those inequalities. So probably have to finish this on a different one. Let's see if we can get this one done. So we have to do a few things, right? We graph it as if it's a line. So up positive 1, slope of 2, so up 2 to the right 1, or down 2 to the left 1. Then we have to say it's a solid line because it's got the equal to. Which side do we shade? Pick a test point. Usually we like 0, 0, but I'll do 1, negative 1. So negative 1 for y, 1 for x. See if it's true or not. So we get 3, negative 1 is less than or equal to 3, that's true. So we shade that same side as our test point. Then we graph the other one, which I'm going to do, and then we'll talk about the answer. So I'm going to pause it. Now when I graph this one, it's a dotted line. Then I'm going to pick a test point. I'll go negative 2, 0. 0 is not greater than 5, so we shade the other side. And the double shaded part is the answer.